Welcome to geometry. Let's see if this works. Thought it would make some adjustments here. This is essentially a continuation of what you guys have been doing with coordinate geometry. Title says coordinate proofs, but you're not really proving a whole lot today. This is just getting used to assigning coordinates that aren't numbers, that are variables. So most of the problems you see today, they're going to be with A's and B's and C's and D's and letters, and just understanding how those coordinates apply to different shapes. So you're going to take a rectangle, take a triangle, you're going to throw it onto a coordinate plane. So it's sort of a combination of geometry and algebra where they sort of overlap. And then you're going to basically assign coordinates. Take a minute and write down the objective just so you understand what the heck we're doing. Applying Cartesian coordinate planes, and the Cartesian coordinate plane, as all of you know, is the x, y axis. Is that two-dimensional plane that we had talked about in Algebra 1 quite a bit. So basically you're going to take a shape and throw it on that coordinate plane and then assign coordinates. And the big thing is you're going to do it with as few letters as possible. Because in a real proof that you might do in, say, Algebra 2 or Calculus, you want to use as few letters as possible to make the proof simple. You wouldn't want to assign all different letters to each of these corners. So I'm going to start off. I'm just going to give you one of these coordinates, and I threw a rectangle onto this coordinate plane. So take a minute, draw a rectangle on your coordinate plane, and I tried to center it so that this point right here is literally bisecting the rectangle, and then the bottom is sitting right on the bottom of the x-axis to make it simple. And we're going to work our way around the vertices of this rectangle, and I'm going to start with this one. This is a comma 0. And just by giving you that information, you can kind of already get some of the dimensions of the rectangle. You already know the length of the entire base here is 2a. And I want you to start to think of those as distances. Even though they're not numbers, you can think of this distance as a, this distance is also a, because I've laid this thing right in the middle with the y-axis as a line of symmetry. And then I'll give you a second coordinate. Up above it is a comma b. And it should make sense that these are both a, because this horizontal distance, which is what we call x, is a for both of them. The height of the rectangle is clearly b. That's what the y-coordinate represents there. Now just by giving you these two, we should be able to assign coordinates to these 2 points. So if I was in class, I'd pause, I'd wait 30 seconds, I'd walk around, I'd see who's got it. You should be able to get a coordinate for this one and a coordinate for this one. In terms of a and b, you shouldn't have to introduce any new letters. That's sort of the whole point of this. And this is probably the easier one. You go, if this is a over here, this has got to be a over here. But we're going the negative direction, so this would be negative a comma 0. And the one up here is pretty easy. Same idea. The height is the same, so the y-coordinate's the same. You're going in the negative a direction on this one. So hopefully that top left would make sense. Negative a comma b. And the bottom left is negative a comma 0. This is what you have to be able to do on your homework. This is kind of the whole point of this section. If I give you these two, can you figure out how to assign these two coordinates without using new letters? So that's the whole purpose of this. So the second part of this, I want you to draw in or attach or join two special triangles on the sides of these. And of course you look at them and go, oh, they're special triangles? Yeah. Join two 45, 45, 90 triangles on the sides there. And then without introducing new variables, assign vertices, assign coordinates to this point and to this one. And if you understand 45, 45, 90s, that's a pretty easy task. Because you know that the height of this 45, 45, 90 triangle is b, because the y-coordinate here is b. And if the height is b, then the distance is also b here. So if I'm going to try to get coordinates to that point, that distance all the way to here is a plus b. And of course we're at comma 0 because there's no vertical component to that. So the coordinates of that point are a plus b comma 0. And again, it just has to do with the distance here is a, the distance here is b, because this is a 45, 45, 90 triangle and these two legs are the same. And then you do the same thing over here. It would be negative a, and then this would be plus negative b, or negative a minus b, comma 0. So that's kind of the whole point. Can you get, if I were to just give you these two coordinates, would you be able to get 1, 2, 3, 4 other coordinates from that in terms of a and b? All right, the second one on your paper, draw that. Draw a parallelogram, and I'm going to give you some coordinates. And your job is to try to complete it. So, I threw the 3 corners up there. On the last one, I threw the y-axis right down the middle. a very common place to place a parallelogram, to place a shape, is with one corner at the origin. It makes the proof simple if you were trying to prove something. So I'm going to give you, bottom coordinate here is a comma nothing, a comma 0. And I'm going to give you the top left. Your job is to figure out the top right. Okay? I'm going to pause this thing. I'm going to come back in part 2 and see if you've got the second set of coordinates there. And that top right should be in terms of A, B, and C. You should be able to get some coordinates for A, so that bottom, for that top right vertex.